Okay, Organic Chemistry 2030, we're going to do our last chapter in number 14. This is our second set of functional group conversions between all the different carboxylic acid derivatives. Okay, so as I said at the end of the last video, we were talking about the interconversion between the different carboxylic acid functional groups and the fact you can always go from a more reactive acid derivative to a less reactive acid derivative. And all of them have to be converted down to the carboxylic acid salt before it can be converted back up to any of the other more reactive groups. So let's dig into that a little bit more, and we're going to start with other reactions you can do with these materials. Okay, so we learned in the aldehydes and ketones chapter that we can do addition reactions on the carbonyl with Grignard reagents. We can do that same thing with esters, okay? But instead of just doing one addition to form that alcohol, we actually end up doing two additions to form an alcohol to get this to happen. So if we use a formate ester or an ester with an hydrogen on this carboxylic acid, so we used formic acid to generate this ester here, we can use two equivalents of the Grignard reagent, and what it'll do is it'll substitute once and then twice and then generate our alcohol. And I'll go through the mechanism in just a minute, but hold on. Okay, so if we have a regular carboxylic acid that has an R group on here, you do the same thing where you do a one substitution with one Grignard reagent, another substitution with another Grignard reagent, generating a tertiary alcohol here. Okay, now notice that these have to be esters. If we had a carboxylic acid derivative, that acid would destroy our Grignard reagent here. It would just deprotonate it and it wouldn't react at all. So we have to use it on esters. Okay, so let's look at the mechanism. Okay, so the first step of our mechanism is the idea that we have this nice polarized bond and we have this negative charge on the carbon here. So it's going to do what it wants to do and attack the partially positive carbon of the carbonyl. That's going to give us this nice intermediate species as the magnesium salt. Okay, so the first thing that can happen here is that then we can regenerate our carbonyl material because we can lose the alkoxide as a leaving group. So our next step is that removal of that alkoxy group here by regenerating the carbonyl. When we regenerate the carbonyl, we've substituted it once on that carbonyl, so we now have a ketone. Okay, so now that we have a ketone, the ketone is going to react with the Grignard reagent just like it did as a ketone, and we're going to get that second addition of a Grignard. So in this second addition of Grignard, we can have a new carbon-carbon bond form. Now we have three carbon-carbon bonds on the system, and we can no longer regenerate that carbonyl. So the reaction stops at the formation of this magnesium salt here, which means to get back to our free alcohol, we actually have to react it with acid and water. So by adding acid to the system, it breaks up the magnesium complex and generates our alcohol. So again, we generate a tertiary alcohol from a regular carboxylic acid ester. We generate a secondary alcohol from a formic acid ester. Okay, so we've been able to do a substitution reaction on that and actually completely eliminate that the carbonyl group here. We can also add hydrogens across that carbonyl just like we did before. In the case of esters, we have to use something very strong. Our strongest reducing agent we have is lithium aluminum hydride. And so we're going to add two hydrogens across that carbonyl bond. When we do, it generates a primary alcohol, plus it clips off the ester group here, regenerating the alcohol used to create the ester. So we get the alcohol from the ester, plus we reduce down the carboxylic acid to its own primary alcohol. Okay, so that being said, sodium borohydride is not strong enough to reduce down the ester. Therefore, you can use sodium borohydride to reduce down an ester or a ketone or an aldehyde. while leaving the ester intact. So if you wanted to get to your carboxylic acid alcohol, this would be a good way to do it, is that the lithium aluminum hydride is required to do the ester. You can use a less strong reducing agent in sodium borohydride and reduce down just the other carbonyl of the aldehyde or ketone. Okay, so now that we have the esters that react with lithium aluminum hydride, but it clips off the alcohol when it does that. When we do this same reduction with an amide, the nitrogen carbon bond remains. So what we end up doing is we reduce down the carbonyl, but we maintain the amine on the final product. So if we look at our first one here, this octanamide here, we have the carbonyl here. It's going to add across that, leaving our primary amine as our product here. If we start out with this tertiary amide here, we're going to reduce down just the carbonyl group, giving us our tertiary amine. In fact, that's one clever way to make tertiary amines, to make them unsymmetrical, is to do them stepwise as reactions on amides and then reduce down that carbonyl. Okay, so that being said, now that we can know that we can go from a more reactive to a less reactive, let's do some interconversions, including the reduction steps here. So starting with this carboxylic acid, in this particular one, we can react it with an alcohol and an acid to generate our ester here. And our ester is more reactive than our amide, which means we can react it directly with an amine to generate our amide. Okay, so if we have our acid chloride and we want to convert it to a more reactive species, we have to use thionyl chloride to create it to our acid chloride, our most reactive species. And then by reacting with an alcohol, we can generate the ester, or reacting it with two equivalents of the amine, because remember it creates HCl and we have to neutralize that base. And so we'll neutralize the acid with a base. We can generate one equivalent of our amide. And now, once we have the ester and the amide, we can use lithium aluminum hydride. The ester reduces down to the carboxylic acid to an alcohol and regenerates the alcohol used to make the ester. But in the case of the amide, it just reduces the carbonyl down, giving you an amine. Okay, and so that takes us through all the different interconversions of carboxylic acid derivatives we're going to study in chapter 14.